Okay, so first of all, there's been a slight change in the presentation, so I won't be focusing always on session border controllers. I'm going to be covering both SBCs, over-the-top services, and unified communications, what's called virtual network functions on NFV, network function virtualization. So VNFs on NFV. So why I'm going to cover this, because there's a few things. Let me see if I can change this. That's it. So what's important to service providers? It's basically, all service providers, they want to increase RPU, they want to attract more customers because a lot of them are going to Skype, they're going to Viber, or they're going to the cheapest operator out there. Also, they want to retain their existing ones, reduce their churn. So basically, it's all about making money while saving money. And that's where NFV and virtual network functions come in. So key thing is the over-the-top effect. You all know all the service providers here in Poland have been, they have the same problem, and not just in Poland, but all over Europe and the world, is that they're getting bypassed constantly by, people like Skype, Viber, etc. And this just shows a diagram from telegeography showing how Skype is, taking a great chunk of the traffic. Skype in 2014, for example, they grew by 30%. So, they're taking traffic away from the ISPs, from the service providers, which is causing, a big problem. And also, a lot of the service providers are struggling to invest in voice infrastructure because, as you know, it's clunky, it's old hardware, and that costs money and OPEX. So just going on, what is network function virtualization? Some of you already know. I'm just going to quickly cover it here. This is a white paper, the first white paper that was published back in 2012 by BT, in which Metaswitch took part. And as you can see, classical network is hardware. Everything was designed on ATCA or on HP blades or Cisco blades, which were dedicated hardware to the application servers, to the media gateways, and the SBCs. What NFV is doing is basically separating that. So now you don't have to worry about dedicated hardware. Everything's on software-based, taking advantage of a whole bunch of underlying processing techniques, which I'll talk about in the next few slides. But essentially, what you're doing here is you're saving money by using common hardware, common spares, and common training. So your engineers don't have to be trained on every single new piece of hardware. Also, we've seen, and there's a whole bunch of research out there that shows that NFV is necessary, and if you guys don't move into that space, you'll end up falling behind and struggle to compete against the telcos. And what this chart is showing is projections from Infonetics of how the blue shows the amount of virtual network functions that are going to be gradually being out there in the field. More and more companies, it's not just voice and multimedia, you're getting RCS, you're having VoLTE, there's a whole bunch of apps out there which are available and being available on virtual network functions versus the hardware and the middle layer, the management and orchestration layer, which is staying constant because there's only a few vendors out there and that's not going to change much. So at the end of the day, you as a service provider would be able to have just a few number of mono-layer hardware infrastructure, very common, and a variety of virtual network functions, which, of course, allows you faster time to market, because with virtual network functions, it takes a few days to install, get up and running, and test. And you can also run it on data centers, on web services. We have our products running on Amazon Web Services. And we've had it for some time. And we've got some carriers, which I'll talk about later on, running on Amazon. So you can actually put your software on generic web services of third parties, do your testing before you go live. Also, it reduces your hardware CapEx, as I mentioned before. You avoid vendor lock-in, because now with Intel's multi-core processors, to be frank, you don't need to have dedicated hardware anymore. So, you might buy a piece of hardware now, in 5 years' time it goes end of life, you switch to hardware, the software stays the same, and you just have more powerful underlying technology. And of course, you reduce your OPEX because you only have one common set of hardware. Why is this possible? mainly because of the way Intel has evolved its processing logic. So Intel started with, before you had single processors, so that required dedicated hardware talking to those processors. Now, starting from 2011, 2012, that was the big break when you started doing multi-core processors. And now you have Intel with, 2 sockets, with hyper-threading, you can have 16 virtual cores, and you can actually manage those cores independently. And basically, in the case of Metaswitch, we've designed our software to manage each core independently for specific functions. I can have cores dedicated to media handling, which is very specific to SBCs. I don't have to have dedicated network processing units, which is the old way of doing things, handling the media. I can now just have generic sockets and dedicate it, one for media, another one for signaling, others for denial of service attacks. Even Intel has added, for example, I can have dedicated CPUs just doing encryption. So that way, by intelligently managing those processes, I can have the same performance as the old vendors, which provide dedicated hardware lock-in. What does this enable to do? Basically, in the case of Metaswitch, we can provide a complete voice unified communication, hosted PBX, IPX solutions, all virtualized. So in this case here, this diagram shows what a typical network is. You can be an ISP, internet service provider, currently doing broadband. And for us, we don't care about the access. As long as you've got broadband, it can be wireline, Wi-Fi, 4G, we don't care. You put this on virtual infrastructure, on a data center, and you have what you call the MTAS, which is basically the application server. It's a SoftSwitch application server all in one, doing your class 4, your class 5 to consumer business, providing over-the-top services, which I'll talk about. And the key point, the most critical component, the SBC, which is your entry and your exit of your network, apart from the TDM connections. So, that is the most critical part. And if you get that on virtualization working correctly, then the rest is pretty much easy. And that's what Metaswitch has done. We've actually concentrated, the first product to be virtualized was the SBC back in 2012. We've got live customers which are public on our webpage. One of them was BT. BT was the first one to go live with our perimeter on virtual infrastructure. Because we managed to demonstrate using the hypervisor technology and using hyper-threading to achieve the performances of the classical SBC. So going through the SBC on the critical component, you can see here, so it's software only. We are, the highest performing SBC with, high capacities. We can do this both on dedicated servers as well as on virtual infrastructure. And we are the only vendor that can provide a complete decoupled architecture, which is also critical when you're going to virtualization and you're going to software only. The SBC should be able to scale in a decoupled architecture where you've got signaling on the one hand, media on the other, and you can actually scale up and down one in the other. So this basically, provides security at max performance, which is critical, and by intelligently managing the different virtual cores, the SBC can handle DOS attacks, header manipulations, NAT traversals, all the security stuff under attack, because we can manage everything independently. Also, visibility. A key thing which is available also virtual with our solution is that we can see every session in real time, not just the sessions, but also the logic handled by the SBC and also our other products in real time. The logic they're using to switch cores, to manage multimedia sessions. We can view that in real time with our service assurance server, which is also available virtual, without actually affecting any traffic at all. Also, using this, you've got to bear in mind, whatever you design has to be able to support the latest technologies, which we've guaranteed. And of course, protocol interworking, which is critical to an SBC and has a big performance hit. When you do protocol interworking, SIP header manipulations, most vendors that have the old hardware architecture mechanisms, they have a big capacity hit for any SIP header manipulation or SDP. By intelligently dedicating CPUs, which I'll show on the next slide, we can actually keep the performances high while doing the SIP header manipulations. Also intelligent routing, and of course has to be carrier grade. This is proven technology. both by customers as well as there's a third-party company called Myacom in the States which have tested SBC vendors from all of them around the world. And they basically have stated that we are the highest performing one in the market. So it's proven technology. It's not just out there on paper. So regarding the SBC, key to SBCs when you want to expand your business, based in and what virtualization enables and software only enables, is that before you had the classical model, which is an SBC, which we provide also, integrated media and signaling. But more and more, especially if you're moving to unified communications and you want to compete with over-the-top, where you have instant messaging, file transfer, file sharing, you've got a lot of signaling traffic there. Also in VoLTE brings a lot of signaling. There's about a 500% increase in signaling when you move from normal classical broadband, I would say, VoIP solution to a VoLTE solution. So that means you need to separate your signaling from your media. Also, the media becomes more complicated. You have way more number of codecs. You've got G729, AMR on the wireless side, AMR wideband, you've got high definition codecs, and not everyone talks to each other. So you want to be able to do your transcoding and separate that and scale it differently too, which is very important. You want to be able to have different cloud solutions where you will have your media on the one place doing transcoding, you're signaling somewhere else, and be able to also distribute your media close to your access POPs while you have your signaling centralized. So you handle all your media locally, which is basically what I was saying here. Let me just go. Also, what this allows you to do is scale automatically. So when you go to a full-blown network function virtualization architecture, you will have your management and orchestration layer. That's what MANO stands for. There are a lot of vendors out there developing those. And what that's supposed to do is look at the resources, the CPUs utilized by the functionality to launch new virtual machines when needed. In this case, I've got an SSC, which is the signaling, just handling signaling, an SBC handling media, which is the blue, and suddenly have an increase in traffic. What happens is the load increases, that gets signaled to the MANO, and the MANO will then create a new instance of a media. So I can increase my media whenever I need, and of course the MANO will inform the control layer, because this does all the signaling and the control. It would inform the control to say, hey, I've just launched another media layer. So now you can do additional transcoding. So, and also I can do it in the opposite direction. So I've done my additional transcoding during peak hours, say, because I needed it. Then I realize I don't need that MSC anymore. What happens is both MSC saying I've reduced my load, goes to the MANO. The MANO will then close that MSC, which will then say, yep, I'm closed, I'm done. So now you've got that virtual machine. You've got extra resources for other things, like at night. Very useful for ISPs that have data centers and using those data centers for other things like video downloads or uploads of enterprise data to a cloud. So you at night. So during the night periods and quiet periods, you use your virtual machines for other things and your CPU resources when you don't need them for voice. And peak hours, you use them for the voice and multimedia. So you adapt your networks. A key thing about the SBC and virtualization is managing the CPU. And this just shows that, for example, how we can do message manipulation, which is what MMF stands for, Message Manipulation Framework, is basically the capability of an SBC to manipulate SIP messages. And if you speak to any SBC vendor, they have a big capacity hit when they do this. The reason being is that they're using the same CPUs for everything. We can, by using, the way we've designed our software is that you can actually manage using, looking at the virtual cores under the virtual machine and managing those cores and adapting them to support message manipulation whenever it's needed. So this shows, for example, before message manipulation, I have core number 3 and core number 4 were empty. I weren't using them because I didn't have any message manipulation. Suddenly, when I needed them, core 3 and core 4 became in usage. So we actually changed those cores and used the cores appropriately to keep the performance high, which is very critical for an SBC. Now I'm going to I've gone from the SBC to the application server side of things. So critical also and available with our solutions on virtualization is now I've got my security, I can scale my security up and down. Now I need to generate new revenue. And the way to generate new revenue is to provide over-the-top services in a secure manner that's easy, intuitive, and already linked to my telephone system. So the difference, we have a solution which is based on our Accession client, which, by the way, we have demos set up on the Systemics. So we are actually a local partner here in Poland, is Systemics, who are trained, certified on our products, and there's a stand when we have demos, and we can do those demos to you. We have this live in hundreds of customers around the world, where our client is actually integrated with a telephone. So you're not using domain names anymore. You're using telephone numbers. So you download the client from Google Shop or from the App Store, you put in a telephone number that gets automatically self-configured. And it gets configured based on what the subscriber is paying. So if you are an ISP or a service provider and you're offering, I don't know, to subscribers video or just instant messaging or voice and instant messaging, the client will be configured accordingly automatically. It's zero touch from the customer. And you can switch between numbers. So now, as an ISP, I'm offering broadband. I've got my broadband access, my router there. I can now offer additional telephone lines to the rest of the family. And that will increase my revenue. Also, I can use them when family members go abroad. I take my Polish telephone number with me abroad. So I can have children which are studying, say, in London, New York, wherever, or in Germany. And while they're studying there, they will have a Polish number. So their friends in Poland will call that Polish number. It's a local call for them, and that gets routed over the internet to wherever they are. So they're taking their Polish number with them, wherever they go. And even when they do calls, because they're doing calls over broadband internet, over any hotspot, that is a local call. So I'm doing local calls wherever I am, so I'm taking my telephone number with me, which is critical and crucial for the residential market. So basically, I'm just expanding the reach. Also, I can provide advanced features and have an upsell. Some advanced features, typical in the business market, I can apply them now to the residential market. One of them is Find Me, Follow Me on SIM-Ring. Very common business features. I can now apply them to the residential market very easily because every subscriber has the capability to manage how they're reached. And they can basically put routes in saying, if my son calls or if a school calls, then do this. First call my wife, then call me, then call my in-laws. I can have different routes. So I can do a SIM-Ring, call all my family members at the same time. So the first person to pick up the call. So these are features that you can upsell to increase your revenue. Also, the same application server from residential, I can then move into businesses. And you can go into a whole bunch of different types of business offerings. You don't have to go all at once. You can start off with SIP trunking. You can do that either with the application server or just with an SPC. You put the SPC there and you trunk and you just do SIP business trunking. You can also gradually add in hosted business services, the full line. So you can basically take your PBXs over from enterprises into a hosted model and get new revenue that way. And even tackle the small and medium businesses. Because with hosted business line, I don't need to have a complete E1 link anymore with a PBX. I can just have 3 lines and have the same feature set as a large business. You can start offering unified communications, call center features, as well as mobile extension. So I can unify my mobile with my fixed line. These we have live in a lot of carriers around the world, and we can go into more details if you come by the stand. Also is fixed mobile convergence. I'm going to cover this. So an advantage with our solution, not just for for businesses, also for residential. I can have one number for my mobile and my fixed line. And of course, a single mailbox. I don't have to have 2 different mailboxes. I can also, in the case of the business lines, my mobile can become an extension of my PBX. So that's new services you can sell there. All this on virtual infrastructure. And you can scale. And the advantage with the solution is that you can start very, very small, a few thousand subscribers, and then scale upwards. And also, if you scale downwards, it's likewise. So it's cost effective, going up and down. Of course, the solution's integrated into Outlook, and so you can have, for business subscribers who use Outlook, you don't have to have a different client, a different SIP terminal. like Xlite or others. It's all integrated into the Outlook, so your business subscribers, even the small and medium ones, don't have to learn a new client. Also, regarding accession, critical when you talk about SIP clients and where we differentiate with, for example, the Skypes, the Vibers, I don't know, PROIDEA terminals, etc., all the Xlite terminals, is voice quality. So this graph shows here is the orange one is voice quality using the MOS score. Blue is Skype, and red is an Android client, and the packet loss is at the bottom. So typical mobile voice quality is 3.0, MOS. PSTN 3.5, 3.8. So with 2% random packet loss, Skype is on the border of being just on the mobile side, while we are still on the PSTN quality. And if you look at 10% random packet loss, we are roughly 3.2, 3.3 in the MOS score, which is still decent quality, while everyone else is way below. Now, on the SIP client, which is provided by with services by our application server, this SIP client, the reason we can achieve this is that we have patented forward error correction mechanisms built into the client to guarantee this quality. Also, with the SBC combined with the accession client is the battery usage. If you grab a Skype client and you leave it running on your mobile for 12 hours, the battery is dead or close to dead. With our solution, and the reason what being this is that most SIP terminals, they use UDP to open the pinholes, because when you're behind a firewall or NAT box, you need to keep the pinhole open. So they're constantly sending UDP, re-registrations to keep it alive, and pings. And that consumes a lot of battery of the mobiles. We've used TCP combined with our SBC, which has intelligent logic to understand the timeouts of the pinholes of the firewalls. So we keep those pinholes open during more time, and it requires less re-registrations from the accession client to keep the battery life. Also, as I mentioned before, it's zero-touch user configuration. The client, there is zero, literally, minimum work for an end user, being a residential or business, to install it. They just go to the Google Shop or to the App Store, download the client, which will be branded with your brand, in Polish or whatever, and then they just put in a telephone number, a temporary password, which they change later on, and the thing gets configured. And it gets integrated with the existing address book. Also, you can tackle the low-income sector by putting advertisements on the client. So I can have advertisement banners on the clients who would pay for those clients, and hence you don't have to, you can target students or low-income residentials with the SIP client. For the business users, we support push-pull. That is a key feature that we can show you guys if you come by the booth. I can be on my mobile phone. I get to the office. I just grab the phone. I can pull the call onto my fixed phone. And the other person won't notice the difference. When I leave the office, I grab the call on my mobile, on my client, and I can just drag it with me when I leave, and the end user won't notice that I've switched and I'm on my mobile. So I can switch between fixed and mobile on the fly, as well as with NFC for Polycoms and Cisco conferencing, which most of them support NFC. I can also jump between my phone and the conferencing terminal just by putting my phone next to that terminal. And critical is also common look and feel. I can be an app user one day, and the next day I might switch to Android because, I don't know, Samsung brings out a new terminal. The actual user interface does not change, which is critical. When I switch terminals or PCs from Windows to Mac, I have exactly the same look and feel and user interface. Now, I'm going to jump from this now, which I've covered now, how can you increase a bit of revenue by offering new services, offering over-the-top services with a SIP client, which is secure, encrypted, using also high-definition voice. Going back now to a work case of using the SBC, which is the most basic functionality, on a interconnect sort of example. So this is an example. I can be, a typical ISP, just offering data at the moment, and I want to move into voice. I can put in a virtual SBC on Amazon, Okay, and I got my virtual SBC running on Amazon, and I start doing just trunking traffic between carriers. That's the most simple and quick way of going into the voice sector. Just by putting an SBC, and I can have, these customers can be either carriers or PBXs, SIP PBXs from enterprises. I'm just trunking SIP PBXs. So the cost, what would that cost an ISP? This is a breakdown of what Amazon charges using 1,500 concurrent calls. So if I've had 1,500 concurrent calls, they have the rental on an average 10%. Using, they also charge for the bandwidth on the processor, so G711 codec, also billing storage if I download daily. So overall, the total cost for the infrastructure of Amazon to run that SBC for 1,500 concurrent cores is 0.02 cents, basically peanuts. So that with an SBC, you start offering voice services and increasing your revenue. So you've actually lowered your cost to go into voice. You don't need big clunky hardware, and you start offering voice, and getting your revenue back very, very fast. The return of investment in these sort of solutions, you're looking at 6 to 9 months maximum, depending on the size. 2 months if you've just got an SBC like this, or even less. Now, this is just on an SBC, but we have a customer I'm going to show on the next slide who actually went big time. This is a customer called Tiscali. They actually used our IMS, which is 100% virtual. They went live back in 2014, I think it was, if I'm not mistaken, or late 2013. And Amazon, they started with 60,000 subs. Now they have 2.5 million subs running on our solution. And they put it on virtual in Central Europe. They've got it on their own cloud infrastructure. And now they've got plans of expanding on Amazon. And the idea is they want to compete with Skype and Viber using our solution. So that's their strategy. And they jumped from 60,000 to 2.5 million subs in just over a year. So it's a solid business case. They've done it. They've gone live, and we've got many more customers now moving into the virtual infrastructure. And just as proof, running our solutions and services, we have loads of customers. Many of these have, our own hardware base, but it's proven technology, proven software. And why Metaswitch for network function virtualization? It's basically, we've been in the business of network function virtualization since the very beginning, since that first white paper published with BT back in 2012. We've been in the business of virtualization. The SBC was the first product. Then we had our IMS core, and then the rest of our products. And of course, very recently, I don't know if you've seen a press release, but AT&T has selected us for their entire network for SBCs. And their plan is to the goal is to virtualize 75% of their network by 2020. When you have a carrier like AT&T, which has literally hundreds of switches out there, and soft switches and a variety of vendors, when they do a press release saying, I am moving to network function virtualization, and I'm serious about it, and I've got SBCs, which is the most critical component, doing virtualization, it means something. So just to sum up, basically, what Metaswitch is doing, and I do encourage you guys to go to the booth of Systemics, where we have our stand, and we can do demos, is that Metaswitch's goal is to empower communication networks over a cloud-based, software-centric IP future. And that is, we want all the carriers to be running software-only solutions for VoIP and multimedia. So we do encourage you guys to visit us, and to come by our booth. And with that, I conclude the speech, and I think on time.